కంపల్సరీ క్వశ్చన్ వస్తుంది 8 మార్కులు. ఓకే, డయాగ్రామ్ రాస్తే 1 మార్క్ వస్తుంది. ఫ్రమ్ డయాగ్రామ్ అకార్డింగ్ టు స్కీమా వాల్యుయేషన్ డయాగ్రామ్ 1 మార్క్. హియర్ what is second pendulum? 1 mark. Simple, what is second pendulum means here? The pendulum whose time period is 2 seconds is called as here second pendulum. The length of the second pendulum here 1 meter or 100 centimeters. 100 centimeters. Okay. First of all, listen. Question number 20. Okay. 8 marks. Gunshot goes marks 8 marks. First statement randy. What is the simple pendulum? First of all, what is the simple pendulum? Nothing but here the spherical bob which is suspended by a thin and inextensible and massless thread is called as here simple pendulum. Is called as here simple pendulum. First of all, see here, this is a rigid support. This one here rigid support, RS rigid support. Okay, rigid support. Here this one here just to length of this one bob, this one here bob. Okay, this is a bob. One side here tie ikkada fixed and another end here attached to the bob. The mass of the bob m, for example mass of the bob here for example m. This is the center of the gravity of bob. Dot means here center of gravity of the bob. Now length of the pendulum, length of the pendulum means this is a point of suspension. This one here point of suspension. The distance between point of suspension to center of gravity of the bob is called as a length of the pendulum. Okay. Simple pendulum statement. Okay. The spherical bob which is suspended by the rigid support by thin and inextensible massless thread is called as a simple pendulum. Is called a simple pendulum. ఇదంతా మీరు రాసుకుంటే అవసరం పట్టే. Now this bob is here initially at rest position, still rest. Now this bob is pull and lose it or push and lose it. Then this bob oscillate about it to its mean position to and fro. ఇక్కడ దీన్ని ఇలా లాగి వదిలినట్టయితే ఏం చేస్తుంటే నిలువుతలంలో ఆసిలేషన్ చేస్తుంది. టు మేక్స్ ది ఆసిలేషన్స్. ఓకే, ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ ఇక్కడికి వచ్చేసింది. ఓకే, ది బాబ్ ఈజ్ హియర్, దిస్ ఇస్ అ బాబ్. ఓకే, అండ్ ఈ డైరెక్షన్లో కూడా వస్తుంది. ఒక 1 చేస్తాను. సో దిస్ ఇస్ వన్ మెయిన్ పొజిషన్ ఎంజీ. ఓకే, దిస్ ఇస్ అ యాంగిల్. సో ది బాబ్, ద లెంత్ ఆఫ్ ద బాబ్ మేకింగ్ an angle theta at point of suspension with vertical line, here theta. This is a angular displacement. This is one here angular displacement. Now for example the bob at point P, for example the bob at point P at any time, the bob at point P at any time. Now two forces acting on the bob at point P, దీనిపైన 2 ఫోర్సెస్ యాక్ట్ అవుతున్నాయి. వన్ ఈజ్ హియర్ mg. సో ది mg, అనదర్ వన్ ఈజ్ హియర్ టెన్షన్ ఇన్ ద స్ట్రింగ్. This is a tension in the string. This one here mg, weight of the bob. These 2 forces acting on the bob at point P. Now the mg dividing into 2 mutual perpendicular components. This mg, weight of the body or weight of the bob, dividing into 2 mutual perpendicular components. Okay, here one is mg sin theta, another one is here mg cos theta. Here this is a dividing into 2 mutual perpendicular components. Here this is a this one here angle. Okay, mg cos theta, another one here mg sin theta, Okay, now mg is cos theta balanced by the tension in the string. mg cos theta balanced by the tension in the string. Okay, the tension acting towards point of suspension, the tension in the string acting towards point of suspension. అంటే ఈ తీగలో ఉన్న తన్యత ఎటువైపు పనిచేస్తుంది, ఏ బిందువు వద్దనైతే నుండి మనం వేలాడదీశామో ఆ పాయింట్ ఆ బిందువు వైపు మాత్రమే పనిచేస్తుంది. ఓకే, ఇది mg cos theta opposite direction. So both are in opposite direction. So these 2 forces are equal. So balanced. So the tension in the string balanced by the mg cos theta. ఇక్కడ 1 point. Next one, the mg sin theta will be try to get its main position to the bob. The mg cos theta will try to get its main position. This force mg sin theta force is called here restoring force. mg sin theta called here restoring force. సో ఈ రిస్టోరింగ్ ఫోర్స్ వల్ల ఈ బాబు అనేది మళ్ళీ మాధ్యమిక స్థానం వరకు వస్తుంది, మీన్ పొజిషన్ వరకు వస్తుంది. దీనివల్ల బికాస్ ఆఫ్ ద mg sin theta. సో ద రిస్టోరింగ్ ఫోర్స్, సో డిస్ప్లేస్మెంట్ ఆఫ్ ద రిస్టోరింగ్ ఫోర్స్ యాంగులర్ డిస్ప్లేస్మెంట్, ఫర్ ఎగ్జాంపుల్ హియర్ x డిస్ప్లేస్మెంట్. ఓకే, నౌ హియర్ వెరీ సింపుల్ కొన్ని సెంటెన్స్ రాస్తా చూడండి. ఇక్కడనే రాస్తా, సెకండ్స్ పెండులం కూడా ఇక్కడనే రాసేస్తున్నా. సెకండ్స్ పెండులం మీన్స్ వాట్ ఈస్ ద సెకండ్స్ పెండులం? The pendulum whose time period is 2 seconds is called as here seconds pendulum. Okay, seconds pendulum statement. Pendulum 1 mark, diagram 1 mark amma, దీనికి 1 mark. Okay, 1 mark. Pendulum whose time period is 2 seconds. 2 seconds is called here seconds pendulum. So seconds pendulum time period enta manaki 2 seconds. Okay, this is a 2 seconds. The length of the seconds pendulum 1 meter. Length of the seconds pendulum enta length L is equal to here 1 meter, that is equal to 100 centimeters. Okay, leave it. డయాగ్రామ్ 1 మార్క్ వస్తుంది. ఇక్కడనే ఈ స్టేట్మెంట్ ఇక్కడ మనకి 2 మార్కులు వచ్చేసినాయి. ఓకేనా, నౌ కొద్దిగా ఎక్స్ప్లెయిన్ చేస్తే టైం పడుతుంది. సరే, ఓకే. వాట్ ఈస్ ద సింపుల్ పెండులం? ద స్పెరికల్ బాబ్ ఈజ్ విచ్ ఈజ్ సస్పెండెడ్ బై ద రాసంగా ఆన్సర్. ఓకే, స్పెరికల్ బాబ్ విచ్ ఈజ్ సస్పెండెడ్ by a thin comma inextensible and massless thread. Okay, massless thread is called as a simple pendulum. Simple pendulum. Okay, simple pendulum. Next, length of the pendulum means the distance between point of suspension to center of the gravity of mass. Here next one oka point raskondi ikkadne. Next point, this point on. Next point, the distance between point of suspension to the center of gravity of bob. Okay, bob is called length of the pendulum. Okay, length of the pendulum. Okay, now here length of the pendulum. ఇక్కడ ఏంటంటే ద బాబ్ డిస్ప్లేస్డ్ సమ్ an angle theta from this vertical, okay, note this one first of all. Length of the pendulum ikkada ayipinda. Next one, this angle is a angular displacement. Note this one first of all. Okay, enough matter. Inka avasaram kunte matter baagane untadi gaani avasaram ledu. The weight of the body mg at p point dividing to two mutual perpendicular components. Here one is here mg cos theta balanced by the tension in the string. Now here second point, tension is equal to here mg cos theta. Tension is equal to here mg cos theta. Here tension in the string balanced by the mg cos theta. Ikkada over of. Next, the restoring force. The restoring force is equal to, now restoring force here F is equal to this one here restoring force minus mg sin theta, minus mg sin theta. The restoring force produced the restoring torque. The restoring force produced the restoring torque. So restoring torque is equal to, now ఇక్కడ ఏంటంటే restoring force దేన్ని ప్రొడ్యూస్ చేస్తుందమ్మా, restoring torque. Now restoring force torque is equal to restoring torque is equal to a restoring force okay into perpendicular distance yeah, perpendicular distance with length of the pendulum, perpendicular distance with the length of the pendulum. This is one restoring force. So both are in perpendicular diagonal, so 90 degrees, both are in perpendicular, so 90 degrees. So restoring torque tau from is equal to here F into here L. L nothing but length of the pendulum, so here F is equal to minus mg sin theta, minus mg sin. So simplifies restoring torque is equal to here minus mg L sin theta, Now theta is very small, where theta is very small, చాలా స్వల్పమైనప్పుడు here sin theta, okay, sin theta is equal to just theta. Now restoring torque tau from is equal to minus mgl theta, this is the equation 1, this one here equation 1, okay. Note this one as it is రాసుకొని సరిపోద్ది మనకి. This is a tau from. So the deflection torque, in deflection torque is equal to I alpha. The deflection, now here deflection torque here, deflection torque tau is equal to here I alpha. This is the equation 2, this one here equation 2. So in equilibrium the restoring torque is equal to deflection torque. In equilibrium అంటే ఇక్కడ P అనే బిందు దగ్గర మధ్య సమతాస్థితిలో ఉన్నట్టయితే ఆ రిస్టోరింగ్ టార్క్ దేనికంటే ఇక్కడ డిఫ్లెక్షన్ టార్క్కి ఈక్వల్గా ఉంటుంది. నౌ నోట్ దిస్ వన్, సేమ్ రాయండి సరిపోతుంది మనకి. హియర్ in equilibrium condition, okay. Now in equilibrium okay, equation here 1 is equal to equation 2, equation 1 is equal to here equation 2. So equation 1 equation 2 ఎంత ఉంది మనకి ఇక్కడ I alpha, that means here tau is equal to here tau is equal to tau prime in equilibrium condition. Now I alpha is equal to here minus mg L theta, here I is equal to moment of inertia is equal to here ml square, moment of inertia is equal to here ml square. Now here alpha is equal to minus mg L theta by here alpha, so alpha is equal to minus mg L theta by I is equal to moment of inertia ml square, Now here cancel, t L square once get cancelled, simplifies here that is equal to minus g theta by L, g theta by here. This is a equation 1, this one is equation 1, okay. This is a equation A, for example this one equation A. Here G and L are constants, that means here alpha directly proportional to alpha nothing but to angular acceleration, this one angular acceleration directly proportional to minus angular displacement. So this is a simple harmonic motion, the simple pendulum making simple harmonic motion. ikkada endante G by L, these are here constants, length of the pendulum and acceleration due to gravity are constants. So angular acceleration is directly proportional to angular displacement, so these two are both are in opposite direction. The negative symbol indicates angular acceleration and angular displacement both are in opposite direction. So this is a So simple pendulum making in simple harmonic motion, executing simple harmonic motion. Now this one here, equation A. Next one, the time period of the simple pendulum. Time period of the simple pendulum, very simple. Okay, here time period of the simple pendulum. Time period of the simple pendulum here. This is the equation. Alpha is equal to here. Alpha is equal to minus g theta by L. G theta by L. Okay, this is the equation here. Now alpha is equal to minus omega square theta. This is the equation B. This is equation B. Okay, this is a simple harmonic motion equation. Alpha is equal to minus omega square theta. Here simple pendulum alpha is equal to minus g theta by L. So equation A and B. A and B. So that means here from B is equal to here A. B is equal to A. So here B means minus omega square theta is equal to A means here minus g theta by L. Okay, here minus minus cancel, theta theta get cancel. So simplies omega square is equal to omega square is equal to g by L. G by L. So simplies omega is equal to under root of here g by L. G by L. So omega nothing but here angular frequency. Angular frequency nothing but 2 phi by t, the time period. So simplies. Okay, notice one. తీసేస్తున్నా దీన్ని. Now this one, time period of the simple pendulum, omega is equal to here, omega is equal to under root here g by L. So omega is equal to simplies omega is equal to 2 phi by t. 2 phi by t. Okay, now 2 phi by t. T means time period of the simple pendulum is equal to under root here g by L. So time period is equal to 2 phi under root of g by L. This is a time period of the simple pendulum. So therefore time period of simple pendulum is t is equal to 2 phi under root of here g by L. This is the answer. ఇక్కడ వారు రాస్తే మనకి 8 మార్క్స్. సో వన్స్ అగైన్ సెకండ్స్ పెండులం, ఎందుకంటే 1 మార్క్ మిస్ అయితే పిల్లలు స్టేట్మెంట్ రాయరు. సెకండ్స్ పెండులం మీన్స్ the pendulum whose time period is 2 seconds is called as seconds pendulum. The length of the seconds pendulum L is equal to 100 centimeters or 1 meter. This is the enough matter. Next one, next question, the law of conservation of energy. Law of conservation of energy and in case of freely falling body. Very most important. Okay, these questions enough. 2 questions. ఈ 3 questions చదవండి మీరు 100% మీకు 16 మార్క్స్ 100% వస్తాయి. మీరు చూసిన తర్వాత క్వశ్చన్ పేపర్లో లేకుంటే నన్ను అడగండి, నేను సమాధానం చెప్తా. ఓకే, లీవ్ ఇట్. సారీ, నోట్ దిస్ వన్ ఫస్ట్ ఆఫ్ ఆల్. నెక్స్ట్ క్వశ్చన్, దిస్ వన్ ఏ వెరీ మోస్ట్ ఇంపార్టెంట్ ఇన్ ఐపీ, టీఎస్ అండ్ ఏపీ. చాలా జాగ్రత్తగా వినండి. ఈ 3 క్వశ్చన్స్ నుంచి 100% 3 వస్తాయి లేదా 3 వస్తాయి మ్యాక్సిమం, లేదా 2 కూడా ఇస్తాడు. మనం రాయాల్సిన 2 కాబట్టి కంపల్సరీ 16 మార్క్స్ మనకు వస్తాయి. నెక్స్ట్ క్వశ్చన్ నెంబర్ 21. క్వశ్చన్ నెంబర్ 21 హియర్, స్టేట్ అండ్ ప్రూవ్ law of conservation of energy in case of freely falling body. In case of freely falling body, first of all statement, state and prove law of conservation of energy in case of freely falling body. చాలా most dangerous important question. Okay, first of all statement, what is the law of conservation of energy? Okay, law of conservation of energy statement here, the total energy in the universe, the total energy of the closed system in the universe always remains constant. It can neither be created nor be destroyed, but one form of the energy converted into another form. This is the law of conservation of energy. అంటే విశ్వంలో ఉన్నటువంటి మొత్తం శక్తి స్థిరము, కానీ శక్తిని సృష్టించలేము, నాశనం చేయలేము, కానీ ఒక రూపం నుండి మరొక రూపానికి మార్చవచ్చు. దిస్ ఇస్ ద శక్తి నిత్యత్వ నియమము. ఇదే మనకు శక్తి నిత్యత్వ నియమం. వన్స్ అగైన్, ద టోటల్ ఎనర్జీ ఆఫ్ ఏ క్లోజ్డ్ సిస్టమ్ రిమైన్స్ కాన్స్టాంట్. ఇట్ కెన్ నైదర్ బి క్రియేటెడ్ నార్ బి డిస్ట్రాయిడ్, బట్ one form of the energy converted into another form. This is law of law of conservation of energy. Okay, this is a statement 1 mark వస్తుంది, diagram కి 1 mark. So in case of the freely falling body, in case of the prove the in case of freely falling body. Okay, అది దేని సందర్భంలో సూచించమన్నాడు, స్వేచ్ఛాపతన వస్తువులో దాని మొత్తం శక్తి స్థిరమని సూచించమంటాడు. వెరీ ఈజీ. ఫస్ట్ ఆఫ్ ఆల్ ఈక్వేషన్ చాలా ఓపిక ఉండాలమ్మా, చదవడానికైనా కానీ వినడానికైనా కానీ, హార్డ్ వర్క్ చేయాలి ఏదైనా కానీ. ఓకే, ఫస్ట్ ఆఫ్ ఆల్ స్టేట్మెంట్ వేసిన తర్వాత ఈక్వేషన్ వేస్తా. ఓకే, హియర్ స్టేట్మెంట్. ఓకే, the total energy of a closed system here, the total energy of a closed system remains constant. Okay, remains constant is known as a law of conservation of energy. Now here constant, it can neither be created here, nor be destroyed, but here one form of energy converted into another form. Okay, is called as here law of conservation of energy. For example, the light energy converting into heat energy, the heat energy converting into light energy. Okay, the heat energy, the mechanical energy converting into, for example, light energy, mechanical energy converting into, for example, heat energy, sound energy. ఇలా రాసింది అనుకోండి. సో ఏమవుతుంది, మెకానికల్ ఎనర్జీ కన్వర్టింగ్ ఇంటూ జస్ట్ హీట్ ప్రొడ్యూస్డ్ ఇన్ బిట్వీన్ 2 యాండ్స్. ఇట్లా రాస్తే ఏమవుతుందంటే మనకి మెకానికల్ ఎనర్జీ ఏ రూపంలో సౌండ్ వస్తుంది అంటే సౌండ్ ఎనర్జీ. సో దీస్ యాండ్స్ ఆర్ హీటెడ్ బికాస్ ఆఫ్ ద రబ్బింగ్. ఇక్కడ ఏంటంటే మనకి ఎనర్జీ అనేది ఒక రూపం నుంచి మరొక రూపానికి రూపాంతరం చెందుతుంది. ఓకే, దిస్ ఇస్ ఈ స్టేట్మెంట్కి 1 మార్క్ వస్తుంది. రాయండి ఫస్ట్ ఆఫ్ ఆల్. Okay, once again, the total energy of a closed system remains constant. It can neither be created nor be destroyed, but one form of the energy converted into another form. This is the law of conservation of energy. Okay, now freely falling body, very most important. Okay, total energy మనం ఏంది, మెకానికల్ ఎనర్జీ, నథింగ్ బట్ ద సమ్ ఆఫ్ ద పొటెన్షియల్ ఎనర్జీ, kinetic energy. The sum of the potential energy and kinetic, that is equal to mechanical energy, that is equal to total energy. Okay, here this one very important amma, chaala jagrata vinandi ga. This is a surface, this one here surface. The block of mass m, let us consider the block of mass small m. Okay, it is some placed at some height from the surface of the earth. So ikkada undi manaki, ikkada undamma some height from the surface. This one here block, point A, mass of the block here m. This block freely falling. Okay, a point A, this one here point B, and this one here point C. Okay, the total energy is constant at every point its path. So direction compulsory ఇట్లా ఉండాలి, డౌన్వర్డ్ డైరెక్షన్ ఉండాలి, లేదా 1 మార్క్ తీయడం జరుగుతుంది ఇయర్ directions. Okay, A point, B point, C point. So the total energy is constant at every point its path. దాని యొక్క పథ మార్గంలో ప్రతి బిందువు వద్ద మొత్తం శక్తి స్థిరమని సూచించాలి. We prove the total energy constant at any point its path. Okay, Now first of all, the body block of mass m at point A, some height certainty h, certainty here h. Okay, first of all total energy randi. Let us consider here, let us consider block of mass m, block of mass m, its height here, its height, okay, height h, here height, here capital H, for example capital H, okay, from surface of earth, okay, from surface of earth. Now total energy at a point, okay, this is a surface of earth, right? 3 points. First of all, when a body is at point B, okay, first one, okay, when a body is at point B, a point, at a point, okay, first a point. The total energy of the at a point, total energy nothing but here, total energy is equal to kinetic energy plus here potential energy, that is equal to half mv square plus here half mgh. This is a total energy, that is equal to here mechanical energy. The total energy at a point, the total energy at b point, the total energy at c point, the totally constant, we prove the totally constant at every point in a b c, its path. Okay, first take on the when a body is at point A. Now potential energy of the body at a point, potential energy, okay, potential energy equal to mgh. A right means here h, height means here h, okay, total potential energy capital H, okay, capital H. And initial velocity of the body at v is equal to u is equal to 0, u is equal to 0. The initial velocity of the block at point A, u is equal to 0. So kinetic energy here, kinetic energy is equal to half m v square, that is equal to half m 0 square, that is equal to 0. Okay, now total energy at a point here, p is equal to t is equal to te is equal to potential energy plus here kinetic energy. So potential energy is this one, here kinetic energy is this one, so kinetic energy is 0. These two are here substituting. Total energy at a point is equal to mgh plus 0, mgh plus 0, that is equal to total energy at a point is equal to mgh. This is at a point, total energy how much here, mgh at a point. Now this block, the body training, so this block to reach the point B, with velocity vb, the displacement of the block from a to b here x, okay, a to b here, for example x, the displacement of the particle here, that is equal to here s is equal to x, okay. The body to reach the point B with velocity here vb. Now the block, height of the block at B from the surface here h minus x, so this one here total h, this one here, this one x minus, so h minus x, that is equal to remaining height. Okay, now the block of the body at B point here, height h minus x, displacement from A to B x, the velocity to reach the point B vb. Now at point P, okay, note this one first of all, this one equation 1, this one equation for example 1, okay, mgh. Now టైం అవుతుంది కొద్దిగా, ఓపికతో నేను వినండి, చాలా ఇంపార్టెంట్ క్వశ్చన్స్. నౌ when point here at point B, okay, Now the body, the block to reach the point here, point B with velocity here, with velocity VB and displacement here, displacement how much here, displacement how much, just x, okay, x, displacement x, and height of the block, next comma, height of the block, yeah, height of the block from earth, from the earth, okay, earth. That means here s is equal to x, here height is equal to h is equal to here, h is equal to here formula h minus x, this is the height of the next here, a is equal to g, downwards direction, okay. Remaining terms here, v is equal to here, v is equal to vb terms. These terms very important, okay. Now this is the, now here potential energy at B point is equal to mgh, h means here h minus x, okay, mgh means h minus x, this is a okay, this one a. Now kinetic energy B is equal to at B point, formula of mvb square to reach the point B with velocity vb, so vb square, okay. Now here from equation, third kinetic equation of motion, v square minus u square is equal to 2as, okay. From v square minus u square is equal to 2as, so these values here substituting, v means vb, okay, square is equal to u is equal to 0, u is equal to here initial velocity, here that u is equal to ikkada rayandi, u is equal to 0 square is equal to remaining 2 into a is equal to g, and here s is equal to just h minus x, okay. Height something, displacement means potential energy, any mistake, height h minus correct, potential energy is, it's okay. Oh sorry, ikkada mistake rasina, height enta itla undamma idi, ee height that is correct, okay. Check up once here, s is equal to sorry ikkada undi chudandi, s is equal to x, is equal to here x, so simplies vb square is equal to 2gx, okay. This one here, this is a substituting here, okay. This values here, vb square values here substituting here, simplies here vb square is equal to 2gx. Now kinetic energy at B point is equal to of m here 2gx here, 2 get cancelled, simplies here remaining kinetic energy at B point is equal to mgx, this is a equation B, okay. Equation 1, this one, equation A, this equation B. Now the total energy of the block at B point, that is equal to potential energy plus kinetic energy, Note this one first of all, as you this kondi, okay. Now from here, potential total energy at B point is equal to potential energy at B point plus here kinetic energy at B point. Here potential energy B point here is equal to mg h minus x and plus here kinetic energy at B point here, this one mgx, mgx. So this one here multiply, this is a multiply inside, simplifies here mgh minus mgx plus here mgx. Any terms cancel here, here this one here get cancelled, this one here get cancelled. So remaining simplifies total energy at B point is equal to just mgh, just mgh. This is the total energy of the block at B point to TEB is equal to mgh, mgh. Next case, the body here to reach the ground with velocity, this block to reach the C point, that means to reach the earth, surface of the earth, with velocity here vc, with velocity vc. The displacement of the particle from A to C, here h, A to C here, this is a displacement, okay, this is a s is equal to, now vc, initial velocity 0, here final velocity vc, displacement here s. The height of the block on the surface h is equal to 0, అంటే నేలపైన ఉన్నట్టయితే దాని యొక్క హైట్ ఎంతమ్మా 0. The potential energy of the block on the surface is 0. So the kinetic energy is here, potential energy converting into here kinetic energy, total potential energy converting into here total kinetic energy. Okay, note this one first of all. కొద్దిగా ఓపికతో నేను వినండి, ఒక్కసారి చదివిన తర్వాత విన్న తర్వాత చదవండి, ఈజీగా అర్థమవుతుంది. గలీజ్గా ఉంది. లాస్ట్ పాయింట్ at C point, at here C point, okay, the block to reach the ground, with velocity here vc, with velocity vc, displacement here s is equal to here h, s is equal to here s, okay, and height of the block here, and height of the block at C point, s is equal to here h is equal to 0, h is equal to here 0, నేలపైన ఉన్నట్టయితే ఎంత ఉంది, h is equal to 0. now here, so here s is equal to h, u is equal to 0, v is equal to vc, here a is equal to g, a is equal to z, and h is equal to here h is equal to 0. This is a information, okay, this one here information. Now here total potential energy at C point is equal to mgh, here h is equal to 0, that is equal to potential energy at C is equal to just to 0, okay. Now kinetic energy at C point is equal to 1/2 mvc square, vc means velocity of the block at C point, vc of mvc square, okay, this is a vc square. From here equation, from v square minus u square is equal to 2as, from third equation here v square minus u square is equal to 2as. so these values here substituting, now these values here substituting simply, here v square means here vc square, okay, vc square, here u is equal to 0, square, okay, is equal to 2 into a is equal to g, s is equal to displacement h, s is equal to your displacement here h, okay. now h simplifies vc square is equal to 2gh, this one vc square is equal to velocity of the block to reach the ground, vc is equal to 2gh. now this values here substituting here, potential kinetic energy at C point is equal to of m, vc means nothing but 2gh, okay. Any terms cancel, your 2 get cancelled, so remaining potential kinetic energy at C point is equal to mgh. Okay, this is the total energy of the block at C point. The total energy of the block at C point. So total energy at C point here, potential energy plus here kinetic energy. C button. Okay, potential energy plus here kinetic energy. So potential energy here 0, kinetic energy here mgh. Okay, implies potential total energy at C point is equal to 0 plus here mgh. Finally, total energy at C point is equal to mgh. This equation here 3. Equation 1 here, equation 1 mgh. Equation 2 here, ikkada em vachindi manaki just mgh. Here equation 3 here, equation 3 here mgh. Total energy is constant. Here total energy is constant. ఏ దగ్గర ఏదే ఫార్ములా ఉందో అదే బి దగ్గర ఉంది, అదే బి దగ్గర ఉన్నటువంటి ఫార్ములా సి దగ్గర ఉంది, కాబట్టి ద టోటల్ ఎనర్జీ ఆఫ్ ద కాన్స్టాంట్. సో హియర్ ఇనిషియల్లీ ద బాడీ హ్యావింగ్ పొటెన్షియల్ ఎనర్జీ, ద పొటెన్షియల్ ఎనర్జీ కన్వర్టింగ్ ఇంటూ కెనెటిక్ ఎనర్జీ టు రీచ్ ద గ్రౌండ్. అంటే ఇక్కడ ఉన్న పొటెన్షియల్ ఎనర్జీ నేలను చేరినప్పుడు మొత్తం ఏ ఎనర్జీ కన్వర్ట్ అయిందంటే ఇక్కడ కెనెటిక్ ఎనర్జీగా కన్వర్ట్ అయింది, కానీ మొత్తం ఎనర్జీ అనేది టోటల్ ఎనర్జీ కాన్స్టాంట్ ఇన్ దిస్ case. Okay, mgh. So from equations 1 2 3 represents the total energy of the block is constant at every point its path. This is the law of conservation of energy. Okay, very important amma. 3 లాంగ్ ఆన్సర్స్ చదవండి. 3టిలో మీకు 100% 3 ఇస్తాడు. 3 ఇవ్వకున్నా కనీసం 2 ఇస్తాడు. ఆ 2 మనకు రాయాల్సింది 2 కాబట్టి 100% మీకు 16 మార్క్స్ 16 మార్క్స్ 100% మీరు గెయిన్ చేయగలుగుతారు. కొద్దిగా ప్రాబ్లం చూడండి. ఓకే, ఆల్ ది బెస్ట్. థ్యాంక్ యూ. మీకు ఏమైనా డౌట్స్ ఉంటే కామెంట్ రూపంలో కామెంట్ పెట్టండి, రిమైనింగ్ కూడా వచ్చేస్తా. ఓకే, ఆల్ ది బెస్ట్. థ్యాంక్ యూ.